So for chapter 2, you should have gathered that these are all the main ideas. So atoms and molecules, water, energy, carbon, isotopes, all of these things are key building blocks for understanding how biology and life around us works. So one of the trickier topics for this chapter is electronegativity. Electronegativity is how strong an atom is pulling on the electrons that are being shared with another atom, So knowing these values helps us figure out what type of bonds are formed between two different atoms. So to find the difference, we want to take the larger electronegativity number and subtract it by the smaller one, and then that will tell us what kind of bond we're having. And so we want to remember that nonpolar covalent, our electrons are being shared equally. For polar, our electrons are spending more time near the atom that has a higher electronegativity number. And then for ionic, the stronger atom basically takes and holds on to the electrons from the weaker atom. And so one way I try to remember all three of these is for polar, I think of like the North Pole. The electrons are hanging out at the pole, they're being pulled to one side, which is the atom with the higher electronegativity number. For nonpolar, I think of no pole. And so I think that the electrons are being shared equally and not being pulled towards any side. And then for ionic, I just think of one atom stealing all the electrons completely. And then so I included this cute little cartoon. See if you can figure out what each of these little cartoons are representing, nonpolar, polar, covalent, or ionic. And then if you think you figured it out, you can ask me if you're right during one of our study sessions. Another tricky thing for chapter 2 is electron shell diagrams. So we want to remember protons. There's a T in that word, so positive charge. Neutrons kind of sounds like neutral, so no charge. And electrons will be negatively charged. We want to remember that protons and neutrons only go in the nucleus. They'll never be in the shells. And the shells will contain electrons. The first shell will have up to two electrons. The second shell and beyond will have up to 8 electrons. And you want to fill up a shell completely with the amount of electrons it can hold before you move on to the next shell. I hope that makes sense. And then the last shell the electrons on the last shell are known as the valence electrons. And those electrons help decide what other atoms that atom can react and bond with. So water really is one of the coolest molecules you'll ever learn about because of all of its properties that it has. So be sure that you know what each of its properties mean. What's the difference between cohesion versus adhesion? Why is water's density when it's frozen so important? What can it dissolve? What can't it dissolve? Just things like that. You'll want to know why water is so important. And then I put another cartoon here for you guys. Each one of these little slides is representing an important property of water. So if you can guess what each property each little cartoon is representing, go ahead and try, and then during my study session, I'll let you know if you have the right answer. So the pH scale can be really tricky, but an easy way that I like to remember it, and maybe this will help you guys, is so say we have a liquid that's a pH of 3 and we're trying to figure out if it's acidic or basic. And so what I do is I like to draw the scale out. And so I draw it vertically, and I always think A comes before B. So what I do is I'll put an A up here and a B down here, A before B, and 1 also comes before 14. So 1 before 14, and 7 will go in the middle for neutral. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 11, 12, 13. And then so like I said, if something has a pH of 3, it's acidic because of our scale that we made, and that's how I remember how to draw out the scale. But just make sure that if you're ever unsure about what pH really means, or how to use scientific notation along with your pH values, things like that, make sure you come to one of our study sessions and ask questions. Okay, so one of my favorite study methods isn't really, I guess, considered studying or memorizing or anything like that, but something that helps me really learn concepts is understanding why that thing matters. So like, why is pH important? Why do we care about the properties of water? Like, what does electronegativity mean, and why does it matter? Why do I care? Things like that. Knowing those kinds of answers really helps solidify things in my mind and make it easier for me to learn them. Another strategy I really like to use is analogies. For example, I like to think of the electrons as them being in a buddy system, and so they always need to be paired up and they need their friend. And then acronyms also help me remember things. And also brain dumps, so talking to somebody else or just brain dumping on a blank white sheet of paper. So make sure that you guys come to one of our study sessions if you have any questions this week, or if you want to brain dump with us, anything like that.